Alright, this is Algebra 2, Lesson 3-6. Today's date is Thursday, October 17th, 2019. I'm recording this a day early because I am at a tech meeting. So, factoring by grouping. This is one of the cool lessons because if you know and you're a master at factor by grouping, you can solve any factoring problem that we've ever talked about in this entire unit. You might be asking me, Mr. Snell, why didn't you teach us that from the very beginning, and then you want to have to teach us all these other methods? And it's because there's a lot of people that don't really like it. I know some of us do. I know Leo's already pretty good at this because I've seen his quiz. I will show you how to do factoring by grouping. So we are going to factor polynomials with 3 and 4 terms today by grouping. So here's my metaphor. If I have 2 apples, and I add 5 more apples, how many apples do I have? And before you say 7 apples, you're right, but it's more, an easier way to think about it for this metaphor is I have 2 plus 5 apples. And you might say, yeah, that does reduce to 7 apples, but 2 plus 5 apples. I add the coefficients of the groups. I have groups of apples. So now I'm changing the apple, and I'm saying that apple is now 3x plus 1. I mean, you can pretty clearly see if I change the 3x plus 1 to an apple, I have the same problem. Well, now how many of these groups do I have? I used to have groups of apples, now I have groups of 3x plus 1. Well, I have 2 plus 5 of those groups, so I have 2 plus 5 of these groups of 3x plus 1. And that is totally correct. And I could simplify this again. That's the equivalent of saying, oh, that's 7 apples. This is really 7 of these 3x plus 1s. It's the same logic. And this is just kind of how polynomials work. They start with numbers, they start with the physical world, and they get really complex really fast. Well, now, instead of 2, I'm changing it to a 2x, and it's basically the same thing. I have groups of 3x plus 1 still, but now how many do I have? I have 2x plus 5 of those groups of 3x plus 1. The way that I say that is I have 2x plus 5 of those groups of 3x plus 1. And when I first saw this, it took me like 4 times to go through this logic to make sure that it made sense to me. If it makes sense to you on the first try, I mean, that's awesome. You might need to replay this part of the video to really see what's happening here. If you still don't get it, try to just go through the rest of the lesson a little bit slowly and see if it still makes sense. Alright, so I kind of boiled down the procedure into 4 steps. Technically, there's a step 0, which is the greatest common factor. You will always do the greatest common factor. But mainly, you need to wisely make 4 terms. Factoring by grouping does require 4 terms. I guess you could do it with any even number 4 or bigger. I wonder if it works for 5 terms. I've never played with that yet, but definitely for 4 terms, it does work really, really well. You also need to find a common group. So I already found the groups for these. They're 3x plus 1. I'll show you how to do that in a sec, but that group needs to be the same group for the left and the right 2 terms. Finally, we're going to factor to leave the common group, so this step has it factored out. And then I'm going to combine the groups into factored form, so it's doing this step. Step number 4 is the step that most students are uncomfortable with, which is why I started my metaphor, which is going from the left-hand side here to the right-hand side. That is doing step number 4. Okay, so how do we see this in the problem? I did a lot of examples because they are hard. The more you see, the more you play, the better you understand. That's just the fundamental rule of math, but here we go. Example number 1. We need to factor this thing completely, which means even if we end up with a perfect square, we need to keep factoring it more and more and more. So what do I see in this problem? Obviously, we have 4 terms, so step 1, check. We already have 4 terms. Sometimes if I have 3 terms, like problems down here, this has 1, 2, 3 terms, 1, 2, 3 terms, then I'm going to have to do step 1. But for now, we're good. Oh, I forgot to check. Ooh, GCF. Does it have a greatest common factor? 5 and 9. Yeah, 5 and 9 are coprime, which means they have no common factor. So we can't do GCF. I should have checked that first. So I can cross that one off as well. So cross, cross, we're good. We're on to step number 2. You will always be doing step number 2 with factoring. That's why I put an asterisk here. Sometimes won't do step 1, and I guess we can put an asterisk on GCF. Sometimes we won't do that. If you want to write that down, you can. Sometimes don't do those steps for this step and this step. But for this one, now that we have our step 1, 2, or step Now 0 and 1 done. We're on to step 2, finding a common group. So if I just look at the right two terms, that's the easiest way to think about these. Look at the right two terms first. If I ignore everything else, kind of cross it off in your mind, what is the greatest common factor of the right two terms? And try to make it so that the first term here is positive. That will make your life so much easier. So I see that 3 is the greatest common factor, but if I factor out just a 3, this first term will still be negative, so I'm going to factor out a negative 3, and we'll make that first term positive. So if I factor out a negative 3x divided by a negative 3 is just x. I took away all the negative 3, and I'm just left with x. And what is 9 divided by negative 3? That is negative 3. So what I've done right here is I have found a group, x minus 3, and that usually will always work if you factor out the greatest common factor of the right two terms. From there, I'm looking at the left two terms. I should somehow be able to get the same group of x minus 3, otherwise I can't do this whole process of combining groups into a factored form for step number 4. So, with that said, I should automatically fill in here x minus 3. It has to be the same group. And the sign here is a minus, so if I put that minus here instead, that would have been better. But anyway, there it is. I have groups of x minus 3. What could I factor out of these two terms to leave me with x minus 3? And I know that a few of you are already shouting, oh, Mr. Sindel, it's 5, obviously. If you factor out of 5, I'm left with x, and I'm left with negative 3. Pretty good, but this is x to the power of 3, x to the power of 2, so I need to pull out the greatest common factor, which is always the smallest, which is x squared in this case. X squared. This is the point where you need to pause, you need to digest the math. What did we just do? This was the kind of the hard step of, like, it will be the hard step every single time that you do it. The tricky step, just mind-bending, is doing this type of work. But this is the hard step I would consider. So we found our groups, same exact groups. You can't have a group of negative x plus 3 and a group of x minus 3. Those are not the same. That's why we had to factor out a negative. So if you ever get groups that look like they're opposites, you forgot to factor out a negative. From here, it's essentially doing this step up here where I said, okay, well, how many groups of 3x plus 1 do I have? Well, now how many groups of x minus 3 do I have? Well, I have, this is going to be, so this line is equal to this line, which is equal to, I have 5x squared minus 3 of these groups of x minus 3. And I can put this in parentheses. So again, 5x minus 3, groups of x minus 3, x minus 3, x minus 3. We see where everything is coming from. Again, you might have to replay this, but there it is. We have factored this, and just checking, can I factor this guy anymore? No. Can I factor that guy anymore? No. If it was perfect squares here, it would be a difference of squares, and I'd factor even further, but there it is. That's as far as I can go. All right, so that completes example number 1. You can box it. So if you are feeling comfortable, you can do example 2 by yourselves, but if I was in your shoes, I would still need at least one more example to get me going. So here I go. I would like you guys to try it, but of course, if you want to follow along, that works too. So step number 0, GCF. Is there a GCF, a greatest common factor? Looks like 2. It might be 4. Oh, 4 doesn't go into 30. 4 goes into 32 though. So I think the greatest common factor here is just 2. There's no x I can factor out because there's no x here. Yeah, it's just 2. So this is going to be equal to, and I might have, yeah, I'll move over here. So it's 2 times, and then when I divide everything by 2, this can be 15x to the power of 3 minus, this divided by 2 is 6x squared, divided by 2 is plus 20x, divided by 2 and minus 8. Alright, so I factored out the greatest common factor. Now I'm on to step 1, which I check off. I already have 4 terms. Good. Now I'm on to step 2. I need to find the greatest common factor, and again, I start on the right-hand side. What is the greatest common factor here, and make sure that this first one is positive? Well, the first one's already positive, so I don't have to worry about factoring out a negative. So I know whatever I'm going to have here, this number right here is going to be positive. So the greatest common factor here is, it looks to be 4. 4. If I factor out a 4, I'm left with 5x minus 2. And just looking ahead, can I get a 5x minus 2? It does look like I can get a 5x minus 2. You will eventually be seeing that. Because this is a positive 4, I'm going to say plus 4 times this. And now I need to somehow get a 5x minus 2, so I have like groups. The groups are the same numbers. What could I factor out of this thing to get me a 5x minus 2? Well, if I divide this number and this number by 3, then I get 5x, and I get minus 2. So 3 is obviously the coefficient. And then I need to get rid of these x squared, so I'm going to factor out the smallest of them, which is going to be x squared. So this is equal to that, which is equal to that. And finally, we do our final step. I could have skipped lines here. I should come down here. Oop, I grabbed the parenthesis. Let's grab you and put you back up there. And then finally, I count up my like groups. I'm on step 4. So how many of these 5x minus 2's do I have? Well, I have 3x plus, my handwriting getting so sloppy, plus 4 of these groups of 5x minus 2. And just do a quick check. Can I factor these any further? No, they're both linear pairs. They both are to the power of 1, which means I can't do anything. And there is our final answer. Alright, so you should be at the point now where you can do this on your own. I am demanding that everyone do example number 3 by yourself. I will warn you, there is a greatest common factor. Do it now, pause the video, and now you've unpaused the video. So the greatest common factor was 3. 3 goes into 6, 9, 18, and 27. Notice that there's no y here, so I can't factor out any variable. I can only factor out a 3. When I factor out a 3, this is going to be equal to 3 times the quantity of 2y to the power of 3 minus 3y squared minus 6y plus 9. So again, I'm looking at the right two terms. I know that I'm going to be factoring out a negative because this term is negative, so I'm automatically going to say negative something times whatever is happening here. What is the greatest common factor of 6y and 9? 3. So I'm going to factor out a 3. I'm left with 2y plus 3. Alright, so that means I should have a 2y plus 3 over here, so 2y, oh my gosh, I made that mistake, didn't I? 9 divided by negative 3 is not a positive 3, it is a negative 3. Undo. This is 2y minus 3, my bad. Again, I was doing negative 6y divided by negative 3 is 2y. Negative divided by negative is a positive, and this is going to be a positive 9 divided by a negative. Positive divided by negative is a negative. I made that mistake, my bad. So over here I should have 2y minus 3. And how do I get 2y minus 3? Well, it's basically there, 2y, then 3. The only thing that's in the way are these pesky y squared, so if I factor out a y squared, I should be good. So y squared. So far, so good. And my final step now is counting how many of these 2y's minus 3's I have, and I have y squared minus 3 of these groups of 2y minus 3. And there's our final answer, I think. Can't factor this one any further because that's to the power of 1. This one has a square, so if this was a 4, then I could do this further. It would be a difference of squares, but 3 is not a square, so that's as far as I can go. And there is my final answer. Alright, so now I'm switching things up a bit. Now I'm giving you only 3 terms. And I know I hear people saying, well, Mr. Sindel, can't we just do the Advanced Ninja Start? And I'm saying, yes, I'm not going to force anyone on a quiz nor a test to use one method or the other. I just want you to play with this method at least for these 2 examples and the homework tonight. And after you play with them using factoring by grouping, then you can use whatever method you want. I just want you to practice with this method so you know what you're doing. So this is a little bit harder. First, step 0. GCF, 5 and 19. 19 is a prime number. 5 is a prime number. They're co-prime. There's nothing that I can divide them by to make them still an integer, so there's no greatest common factor. We're on to step number 1, which we're finally doing. We've never done step 1 before. This is the first time we're wisely making 4 terms. So we need to wisely make 4 terms, which means I still have a 5x squared. I still have a plus 12. The only difference now is I have 2 terms here and here that I make out of the middle term. You will always make this middle term split in half. You're splitting the middle. Maybe that would be a better way of writing this. Splitting the middle. I'm going to write it down here because I think that'll help. Split the middle term. So this 19x, I need to somehow split that up so that I can get a nice group like I had up here of 2y minus 3. So let me show you one that doesn't work, so I don't want you to write this down. And it will take some practice to get these, and this is the one that Leo is a master of. I think Leo, maybe this is the first time you're seeing with 4 terms, but you've seen 3 terms many, many times before. So with this one, let's try, I don't know, let's randomly do it. Let's say, oh, let's try plus 5x, which means I'm left with plus 14x. Okay, that's not going to work. I'll show you why. The greatest common factor over here is 2, so I'm going to have 2 times 7x plus 6. And can I somehow get a 7x plus 6 from 5 and 5? No, I can't. So I didn't wisely divide up I didn't wisely divide the 19x into 2 halves. So let's try again. And as a general rule of thumb, if your last number, Command Shift Z, if your last number is bigger than your first number, that means your last half is going to be bigger than your first half by about the same proportion. I think by exactly the same proportion. So I'm thinking, okay, this number right here needs to be big. This number needs to be small. I think I might have said that backwards in the video. I hope I didn't. But this number right here, 100% needs to be bigger. This number needs to be smaller because this, I think you'll just see. So let me try something else. Let's try 15, something big, 15x. You want to write this one down because I'm doing it correct now. 15x, and I'm going to do plus 5x. So when I do it like this, I'm making it so that these have some sort of factor that I can factor out. If I chose like 11x, then obviously I couldn't factor anything out. So now I'm going to do the same procedure again. I have wisely picked the middle terms, and you'll see over here, 5x plus, what is going on? That's not a 5x, that's a 4x. Oh my god, Mr. Sindel. I apologize. 15 plus 4 does equal 19 if you caught that log in your extra credit tracker. 4x plus 12, the greatest common factor there is 4. So I'm going to say 4 times, and it is a positive, so I'm going to leave it as a positive, good. Positive 4, and then I'm left with x plus 3. So 4 times x plus 3, and then over here I'm going to have the same group of x plus 3. How can I get x plus 3? Well, I factor out a 5, and I'm left with x plus 3, and then I need to get rid of that x as well. So I'm going to have 5x times x plus 3, and you can check your work here. I can write that a little bit closer. You can check your work. 5x times x is 5x squared. 5x times 3 is 15x. So far, so good. And then we count up our terms. How many of these x plus 3s do I have? I have 5x plus 4 of these groups of x plus 3. And there's our final answer. I think, yeah, these are both linear terms. They both are to the power of 1, which means I cannot reduce any farther. 5x plus 4 times x plus 3 is our final answer. And you can check really quick too. Advanced Ninja Star will give you the same exact answer. So the one thing I want to say before I let you try number 5 on your own is factoring by grouping will work on any single problem that we've dealt with this unit. It will work on difference of squares, it will work on perfect squares, it will work on things that you use Ninja Star, it will work on things that use Advanced Ninja Star. It is the rule that it'll solve any problem that we've ever done. You just have to be a master of it. You don't have to watch it, but I'll probably link a video, or not link a video, I'll just include the video at the very end of example number 5 if you want to watch how to do like a difference of squares by factoring by grouping or something like that. Alright, so example number 5 has a greatest common factor. With that hint, I want you all to try example 5 by yourself, and it is going to be one of the most difficult problems on this piece of paper. So please try it, at least give it your best shot. And now you've unpaused the video, here we go. The greatest common factor was 3. 3 times 9x, 3 times 3 is 9. 3 times 3x squared minus 7x minus 6. Alright, so far so good. Now I need to make my 4 groups. So I'm on step 1. I just did step 0. Step 1, my 4 groups. So I still have that 3. It doesn't go anywhere. I still have my 3x squared. I still have my minus 6. Now I need to find these 2 middle terms. So I'm thinking if I have 7, I should probably make this one 2 and 5. No, that's not going to work. Let's think if I made this one 3 and 4, that's not going to work. What about 6 and 1? That's not going to work. What about, this is going to be difficult. Ooh, I think I'm going to have some sort of negative. So if I have maybe negative 10x, This is a difficult problem. I haven't even seen it before either, and I'm not by any stretch of the imagination a master by grouping. Alright, I'm going to cut the video and I'll figure this out on a piece of paper so I don't waste your time. Alright, so I'm back, and yeah, it took me about 2 minutes off camera to get this to work. I ended up going with 3x squared plus 2x and minus 9x. So they do add to negative 7x, and you'll see that when we factor them, we will have like groups. I think this is the only possible answer. If there's another one, then if you catch that, I will give you extra credit, but I think that's the only possible answer. So if we do this, let's switch to black here. The greatest common factor over here is 3. So 3 times what? But make sure that this number is positive, so I need to factor out a negative 3. So when I factor out a negative 3, I'm left with 3x, and then a positive, because a negative 6 divided by a negative 3 is a positive, and a positive 2. So that means I should have 3x plus 2 over here as well. So I'll make my parentheses, and I'll say 3x plus 2. What will give me 3x? Oh, there it is, 3x plus 2. Haha. All I need to do is pull out an x, and don't forget my 3 out front as well. So 3 is being multiplied by all of this stuff. Now I need to count how many of these 3x plus 2's do I have. I have x minus 3 of the 3x plus 2's, and don't forget that 3 out front, and there is my final answer. They're hard, obviously. I need some practice as well. I'm going to go make that video showing you on how factoring by grouping can solve other types of problems that you've seen before. So I was going over example 5 a few times, and I wanted to explain an easier way to get these two numbers using the properties of our advanced ninja star, because they're very, very similar. If you can't find out those two numbers, an easier way to do it is to know that they obviously have to add up to negative 7, but also multiply negative 6 times 3. These two numbers should also multiply to the same thing. Negative 6 times 3 is negative 18. Then you have to ask yourself, well, what times what is negative 18? And you just start going through all of those factors. And you need to make sure somehow you get 7. So here we go. 3 times 6 is 18. 18, 1 and 18. No, that doesn't work. 2 and 9. That one did work, and it ended up being the answer. I don't know, let's try 3 and 6. 3 and 6 is 18. 3 and 6 can't get 7. Once you figure out that 2 and 9 are the answers, then big pairs with big, small pairs with small, and then make sure the correct one is negative. If this is negative, then the big one is negative. It's kind of a lot of things to just think about while you're solving it, but it does help quite a bit. Again, multiply the last and the first, 3 times negative 6, and these two numbers must multiply to whatever these two numbers multiply to as well. I hope that helps. Before I show everyone how to use grouping to solve all the problems that we've done before and a few short examples, I just wanted to show everyone that it is possible to use Advanced Ninja Star on difference of squares and perfect squares, and then we can move on to factoring by grouping for all the rest of the problems. I just want to point out that the rest of the video from here on out is totally optional. You're doing it because you're curious about math, or you want to see maybe how to be a master of factoring by grouping, because if you are, then you can use that one skill over and over and over again. Okay, so you're watching this part of the video because you want to see how the Advanced Ninja Star can even work for perfect squares and difference of squares. So here's a difference of squares. Obviously you have two squares with a minus sign in between. How would I set this up for Advanced Ninja Star? So this can be rewritten as x squared plus 0x minus 9. I think we can all assume that 0 times x is 0, which does get us to this form. When I set up Advanced Ninja Star, I have 1x, I multiply negative 9 times 1, and that's going to be negative 9. 0 goes on the bottom, and I ask myself, what times what is negative 9 that adds to 0? And the answer is 3 and negative 3. I reduce the fractions. I can't really reduce fractions, and I get x plus 3 times x minus 3. This will work on any difference of squares problems. You can do really big ones too. I want to also show you a perfect square that it also works. So for perfect square, let me just do a nice and easy one. X squared, and if I do my last term of, I don't know, 4, that's not a good one. Let's do 36. So that means it's plus 6, so 12 plus 12x. This is a perfect square. I know the answer already is going to be x plus 6, and that's not a 6, x plus 6 quantity squared. That's our answer that we're trying to get to. We should be able to get there with Advanced Ninja Star. So using my Advanced Ninja Star, we have 1x, 1x, 36 times 1 is 36, bottom is 12. What times what is 36? That also adds to 12, and the answer is 6 and 6. You can't reduce those fractions, so your answer is 1x plus 6 times 1x plus 6, which does turn into the final form of x plus 6 quantity squared. So Advanced Ninja Star does work for difference of squares and a perfect square. Although the one thing that it doesn't work on, as I mentioned in the video, is it doesn't work whenever I have 4 terms. Whenever I have a quadnomial, I guess. I don't know if that's a commonly used term, but whenever I have 4 terms, this breaks apart, or at least I played around with it for only 10 minutes, and I couldn't figure out how to make some sort of pattern like this to work for 4 terms. The only thing that works for 4 terms and perfect squares and difference of squares and other types of problems, other trinomials that you can factor, is factoring by grouping. It is the one true way to solve any of the factoring problems that we've encountered thus far. Alright, and now on to factoring by grouping for every single type of problem that we've seen this unit. This will help immensely if you are struggling on the homework for tonight. Again, totally optional. So if I have x squared plus 2x minus 24, this is a simple, you would normally use normal Ninja Star to do factoring by grouping. I'm going to turn this thing into, so I have my x squared, I still have minus 24. From here, I'm asking myself, what, since I have a coefficient of 1 times negative 24 is negative 24. What times what is negative 24 that also adds to 2? So 6 and 4 are the things that pop into my head. So, and which one is bigger? This one is bigger, so 6 will go over here, 4 will go over here. Both of them have an x in it. In order to be positive, this one should be positive, this one should be negative. And from there, I factor out the greatest common factor of both of the 2 terms. So for the left 2 terms, it's just x, and then I'm left with x minus 4. On the right-hand side, I'm left with, if I factor out 6, it's going to be positive 6 being factored out. I'm left with an x minus 4 again, and this simplifies to x plus 6 groups of x minus 4. For my second problem, I want to do something that you use Advanced Ninja Star. We basically saw one of these in the notes, but I'll do another one just to show all of them in one place. Let's try 6x squared minus 11x minus 10. And by the way, I'm not just pulling these out of my head. I've been working on this for like 15 minutes off on the side to find some good examples for you guys. So to do this one, I should be writing equal sign on all of these. And notice I'm not doing any greatest common factor because that's pretty straightforward. It's the same process over and over. I'm going to pull them apart, 6x squared minus 10, and I need to ask myself, so 6 times negative 10 is negative 60. What times what is negative 60? And you might be thinking, oh, 6 and 5. But one of them would have to be positive, and one of them would have to be negative to get a negative 60. They both can't be negative, otherwise you get a positive 60. So try going, oh yeah, 15 and 4. 15 and 4. So 15 is bigger, it goes with the bigger. So 15 goes there, 4 goes here. And I need to make a negative 11x, so negative and positive. And then from here, it's just factoring out the greatest common factor. So it's going to be 2x for the greatest common factor, which leaves me with 3x plus 2. And I should have a 3x plus 2 over here as well. And to get a 3x plus 2, I have to factor out a negative 5. And how many groups of 3x plus 2 or 3x plus 2 do I have? I have 2x minus 5 of those groups of 3x plus 2. Advanced Ninja Star. Cool. Let's see difference of squares. So in number 3, a difference of squares would look like this. Let's try kind of a hard one. 81x to the power of 2 minus 64. Obviously they're both squares. How do I do this? Again, you pull them apart. 81x squared minus 64. Now these two numbers that I find here and here have to cancel each other out, so they should be the same number but opposites. So the way that you do that is you kind of cheating a little bit. Take the square root of both those numbers and multiply them together. So the square root of 81 is 9, the square root of 64 is 8. 9 times 8 is 72, so it's going to be plus 72x minus 72x. You just put negative with negative, positive with positive at this point. And then greatest common factor yet again. And I don't know why I'm doing this all in blue. I should be doing this in black. And I should be moving this a little bit over here. So from here, the greatest common factor is 9. So I have 9 times 9x. 9x. And then I'm left with 9x plus 8. What can I factor out over here? I can factor out an 8. Then I'm going to be left with, I need to factor out a negative 8. So negative 8, and I'm left with a 9x plus 8 again. Good, the same two groups. And how many groups of 9x plus 8 do I have? I have 9x minus 8 of those groups. 9x minus 8 of those groups. So a little bit tricky, but that's how you become a master of factoring by grouping. You have to know all the tiny little tricks on that one method, and then you got them all, right? Our final example is going to be example number 4. Let's do a perfect square. So a good perfect square for us is 9x squared plus 30x plus 25. So this perfect square, I think that these are really, really easy with factoring by grouping. So 9x squared and then 25. They're easy because you literally are doing the same thing that you did over here, but it's dividing this number in half always. So 15x and 15x. So plus 15x plus 15x. And the reason that I know that it's the same process, if I square root this, it would be 5. If I square root this, it would be 3. 3 times 5 is 15. That's where the 15s come from, just like I had over here. So from here, I'm going to factor out the greatest common factor of 3x. And when I factor out 3x, I'm left with 3x plus 5. I should have 3x plus 5 over here as well. And how do I get that? I have to factor out a 5. And it's a positive 5. So how many groups of 3x plus 5 do I have? Well, I have 3x plus 5 of those groups of 3x plus 5, which is just equal to 3x plus 5 quantity squared. So that is every single problem, or every single problem type that you will see on the test, all of them solved by grouping. Thank you for watching.